In this video, we will look at comparing signed numbers. We are already familiar with the natural numbers and the whole numbers. The integers consist of the whole numbers and their opposites. A number line for the integers starts at 0 and continues indefinitely in both directions. Here is such a number line. We've got 0 at the center. Going back this way, we've got -1, -2, -3, -4, -5, -6, and that would keep going on to negative infinity. And we already know what the right side of this number line should look like. The opposite of a number is the number which is the same distance from 0 but in the opposite direction. Integers are called signed numbers because they are often written with signs that indicate on which side of 0 they will fall. Positive numbers, such as 1, 2, and 3, are sometimes indicated with a plus sign to show that they are greater than 0. The plus sign is not necessary, as a number with no plus sign is positive by default. A number with no sign, I should say, is positive by default. Negative numbers, such as -1, -2, and -3, are always indicated by a negative sign to show that they are less than 0. Integers are not the only sort of signed numbers. Fractions, mixed numbers, and decimals also have values less than 0 and are part of the greater sets of rational and real numbers. To compare signed numbers, mentally position them on a number line. Then the leftmost number is the smaller number. If the smaller number is written first, put a less than sign between the numbers. If not, use a greater than sign instead. In this example, we'll use these symbols, less than and greater than, to show the relationship between each pair of numbers. First, we've got 7 and 9. If I write those on a number line, 7 will be to the left of 9. So I use a less than sign to show that 7 is less than 9. Next, we have 0 and -1. If I put those on a number line, -1 comes before 0. It's to the left of 0. So 0 is greater than -1. -4 and -2. Actually, I've done all of this here, so I don't have to do that there. 7 is less than 9. That's pretty easy. The negative in -1 implies that -1 is less than 0. So -1 is less than 0, and that means that 0 is greater than -1. We've got -4 and -2. While 4 is greater than 2, both -4 and -2 are less than 0, and -4 is 4 units away from 0, while -2 is only 2 units away. Therefore, -4 is less than -2. Finally, we've got -2 and 0, and -2 is less than 0. The absolute value of a number is the distance between that number and 0. Distance is always positive, or 0, because it represents a physical property. It cannot be negative, and neither can the absolute value. To find the absolute value of a number, let A be a real number. If A is greater than 0, the absolute value of A is A. If A is less than 0, the absolute value of A is -A. And if A is equal to 0, the absolute value of A is also 0. Note that if A is negative, -A is positive. A double negative in math means a positive. So now we're going to find the values of a couple of numbers. We want to find the absolute value of 9, and that's 9 because 9 is greater than 0, so it's its own absolute value. -4, the absolute value of -4 is +4 because -4 is less than 0. So the absolute value of -4 is -4, and that double negative makes a positive, so that's +4. Every number except 0 has an opposite. The opposite of a number is also called its additive inverse. A number and its additive inverse have the same absolute values, but opposite signs. To find the additive inverse, find the value that has the same absolute value and opposite sign. So As an example, we'll find the opposites of some numbers. The opposite of -8 is going to be the absolute value of 8, the absolute value of -8. I should say that we're going to take the absolute value of -8, and that's 8. And we just put the opposite sign on it. This is a negative, so we make it a positive, which is 8. Here, the absolute value of 6 is 6. We put the opposite sign on it and get a -6. The absolute value of 0 is 0. -0 is equal to 0. 0 is its own opposite.